we need to talk about reference angles. I'll give you a minute to read the definition of a reference angle that's there on your screen. Stop the video if you need to. And there are some things that I want to kind of emphasize about this definition. First of all, we're defining angle theta as a non-acute angle, so it's bigger than 90 degrees. The angle is always in standard position, and we make a point to say that it lies in a quadrant. And that just means that theta is not the terminal side of theta can't be on one of the axes. You actually have to have the terminal side in a quadrant, not on an axis. Okay, the other thing I want to emphasize is that the reference angle, theta prime, is positive acute, and it's formed by the terminal side of theta and the x-axis. Now, let me give you a picture. Suppose we have, imagine that x-axis is actually, there we go, horizontal. Suppose we have angle theta somewhere in the second quadrant. So, there's theta. So if this is our angle theta, then the reference angle is always measured back to the positive x-axis. And we're just interested in the size of that angle. So the reference angle theta prime is the angle that I've indicated there in blue. We're not worrying at all about what direction angle theta might have been measured in. We're not thinking negative rotation or positive rotation. We're just thinking how big is that angle if you go back and you measure to the x-axis. So you measure down to the negative x-axis if angle theta is in the second quadrant. If angle theta is in the third quadrant somewhere, so we might have this angle for theta, then the reference angle again is measured back to the that's the negative x-axis. So theta prime would be there. Again, don't worry about the fact that that angle is below the x-axis. That doesn't matter. What's important is how big it is. If angle theta is in the fourth quadrant, and all of the angles theta that I've chosen to sketch have been positive angles, it doesn't matter. We could be talking about the negative angle. But still, measure to the x-axis, and there's your reference angle. So let's look at some specific examples. If our angle is 210 degrees, 210 degrees, remember, is the same thing as 7 pi over 6. So that's one of our special angles. I would expect you to know where that is and be able to sketch something reasonable for 210 degrees. So you're thinking about how far beyond 180 degrees did that angle rotate? What's the difference between 210 and 180? And the reference angle in this case would be 30 degrees. If theta is 7 pi over 4, another special angle. Okay, we know where 7 pi over 4 is. So we think about, again, thinking in radians this time since theta was given to us in radians. What is that angle measured back to the x-axis? And that has to be pi over 4. In other words, we're comparing 7 pi over 4 to 2 pi. What's the difference between 2 pi and 7 pi over 4? Maybe, let's look at a negative angle. Negative 240. 240 degrees. Let's see. Be about right there. So we're rotating in a negative direction. Finding this angle, then we're thinking about how far beyond negative 180. What's the difference in 240 and 180? And that angle is 60 degrees. So we rotated 240 degrees in a negative direction, but we just are comparing the number 240 and the number 180 degrees. Now, it's a little more interesting if we have an angle measured in radians that's not one of our special angles. Take theta equal 3.6, for instance. What do I know? I know that pi is approximately 3.14, so 3.6 has got to be just a little bit beyond pi. 3.6 is in the third quadrant. So we need to compare 3.6 to pi. And if you do that subtraction, 3.6 minus pi, you get something that is approximately 0.46 radians. So the reference angle would be 0.46 radians. If your angle is larger than 360 degrees, we can still think about reference angles. So larger than 360 degrees or larger than 2 pi radians. So what about 665 degrees? First, you have to figure out where that is. So subtract, since 665 is greater than 360, I would subtract 360 degrees and realize that this angle is coterminal. 665 is coterminal with 305. I can estimate about where angle 305 degrees would be. That's not it. Maybe about right there. So 665 is one complete rotation plus another 305 degrees. To find the reference angle, I'm going to think about 305 and subtract that from 360, which would give me an angle of 55 degrees. If I did the subtraction right. Yeah, that's right. Same thought process if you have an angle measured in radians, like 15 pi over 4. To figure out where 15 pi over 4 is located, and you'll notice in each one of these examples, I start with a picture. And to figure out where 15 pi over 4 is going to be oriented on the coordinate plane, you know, what quadrant does that fall in? Is it close to the x-axis? Is it close to the y-axis? Whatever. I think about what angle it's coterminal with. And if I subtract 2 pi from that, I believe we get 7 pi over 4. Yeah. I know where 7 pi over 4 is. It's right in the middle of the fourth quadrant. So 15 pi over 4 is a complete rotation plus another 7 pi over 4. There's 15 pi over 4. And the reference angle is pi over 4. One more. A negative angle this time. Negative 11 pi over 3. Now, this time to think about coterminal angles, coterminal angles. You notice that each of our coterminal angles was a positive angle, 305, 7 pi over 4. So I'm going to add 2 pi to this. Okay, if you add 2 pi, 2 pi is 6 pi over 3, so that would be a negative 5 pi over 3. And that's still a negative angle, but I can estimate kind of where that is, or I can add another 2 pi and get positive pi over 3. So negative 11 pi over 3 and positive pi over 3 are coterminal. I know where pi over 3 is. It's about there. So the angle negative 11 pi over 3 is 2 complete negative rotations plus another 5 No, I'm sorry. Yeah, that's right. Since it is coterminal with pi over 3. Now, this is interesting. I believe this is the first one we've looked at where the terminal side is in the first quadrant. Think about that. Fourth quadrant, second, third quadrant, third, fourth quadrant, second quadrant. This is the first time we've had an angle that's in the first quadrant. And I go back and I want to make sure that I can work with the reference angle. Angle theta has to be non-acute angle in standard position, which we have, and it lies in a quadrant, which this does. If your angle ends up in the first quadrant, then the reference angle is the angle that it's coterminal with. I wouldn't worry too much about thinking about it that way. I would just think about, what is that angle there in the first quadrant? We know it's pi over 3, so that's the reference angle.